Alright guys, so today we're going to be working with the slope of a line, and it sounds like most of you have already at least been introduced to it, yes?
Yes.
In pre-algebra. So some of this should be reviewed, some of it should be new. Okay, so first thing we need to do is define what slope is. Slope is the rate of change of a line. So it means that, like, you know when you're walking up a hill and you say it's a really steep slope? That means that the steepness of the hill is changing at a certain rate, and so that's kind of the same thing. Slope means how steep is a line. Okay? We do have an equation for slope. Does anybody know what variable is equal that we use for slope? That's close. That's what we are going to be filling in, but what's the variable?
R over R. No.
For slope. Slope is the same as
X1 minus
M. So will you guys write that in? M means slope. Okay? So M means slope, and then now you guys have know what it is. Vertical change over horizontal change, or rise over run.
What does M stand for again?
N stands for slope.
Why?
I have no idea. It's just the letter we use for slope. You know, like T is always time? Yeah. It's because S is seconds. Yeah. So we had to just pick one, and it's M. Okay? So, to find the slope, we have some steps. First step is to pick 2 points. So, when we are given a graph and they ask us to find the slope, we just need to pick 2 points, and we count the number of units up or down. That's our rise, the up and down, from the first point to the second point. So how many up or down? If I'm going down, what do I need to make sure I count that as? Negative. Okay, so if I have to move down, it needs to be negative. We do the same thing, but now we have to count the run, which is side to side. So we count the number of units to the left or right. From the first point to the second point. And so if up is positive and down is negative, is left positive or negative? Negative. Is right positive or negative? Right is positive on a graph. Okay, so if you are going to the left, it's negative. If you are going to the right, it's positive. Okay, and then step 4, we want to write our slope as a fraction. Okay. The only time we don't have to write it as a fraction is if the denominator is 1. Okay. So if the run is 1, you don't have to write it as a fraction. Okay. So let's look at example 1, and we'll actually do this. Okay, so they picked 2 points for us, so all we have to do is count the spaces, and we always want to do rise first, so that means up and down. So we can either start from this point, or we can start from this point. Which one do you guys want to start at? 3, 4, or negative 2, 1? 3, 4? Okay, let's start at 3, 4, and we're going to count how many spaces down to get me to negative 2, 1. So I'm going to start it already, M equals, and then let's count. This is very light. 1, 2, 3 spaces. To get from 4 to 1 is 3, so the numerator is going to be 3 over. But I went downward, so is that positive or negative? Negative 3. And then I'm going to go to the left, so is that positive or negative? Negative. 1, 2, 3, 4, 5, right? Is that what it is? 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5. So negative 5. Yeah, I know. It's really hard to see. I have it printed out, and it's a little bit easier. So is this my answer? I have a negative over negative, so what does that mean? It's positive. So my slope is actually positive 3 over 5. And that's your answer. All they wanted us to do was count the slope.
Wait,
Are they gonna have like squares?
would it be the, would it
Yeah,
be
it
vice versa?
actually does. But I'm going to start at the lowest point this time. So I'm going to start as m equals, and we are going from 1 to 2, so that's one space, so 1 over, and I was going up, so it was positive. And I'm going from this 3 to negative 3, so that's 1, 2, 3, 4, 5, 6. But I'm going to the left, so how many spaces is it? Negative 6. So that's my slope. That's your answer. It can't be reduced anymore, so we are done.
Wait, do you always go?
Okay, counting on the graph takes a long time, and sometimes it can be inaccurate if you're not really, really careful about your counting. Okay, so there is a formula for finding the slope. Okay, so slope equals, we call this, the rise is the difference between the y values, right? Because we're only looking up and down. So we call that y1 minus y2. Okay, so we subtract the two y values of the points. To find the run, that's the x values because it's going across. So that is x1 minus x2. Okay, and then we have to write this part right here. x1 minus x2 cannot equal 0, which means the denominator cannot be 0. What happens if the denominator is 0? If the denominator is 0, can we have a 0 in the denominator?
No.
So it would be undefined. Is that mine?
Yeah.
It's undefined. The slope will be undefined if our two x values end up being the same. Because let's say x and both x's are 7. 7 minus 7 gives me 0, right? But remember from what we've learned before, that if you have a number over 0, what does that give you?
0.
No. Can you divide by 0?
No.
No. 0 can be on top, but 0 cannot be on bottom. It's undefined.
Oh yes, that's mine.
So we just have to make sure that if we get, and we'll do an example of, if we get a denominator of 0, that's called an undefined slope, which means that the line is straight up and down. Okay, we'll do one. So we can find the slope from a graph by counting, but we can also just be given 2 points and find the slope from those 2 points. So what we're going to do is we first need to look at the y coordinate, so we plug in the 2 y coordinates for y1 and y2. Okay. Step 2, we do the same thing with the x coordinates, so we plug in the 2 x coordinates for x1 and x2. But then right under here, I want you guys to underline it, put stars next to it, whatever. You need to make sure that when you plug in the x coordinates, that the x's are in the same order that you put the y's in. Okay, so the same point should be on top of each other. I'll show you when we do an example, okay? If you put them in different orders, then your answer is not going to be correct. Okay? Okay, step 3, we simplify and reduce if possible. So we actually do the subtraction, and then we reduce our answer if we can. Okay, now before we do a couple examples, we do have a nifty little chart. We will be able to quickly check our answer by the picture on whether or not the slope is positive or negative. So which direction do we read, from left to right or from right to left? From left to right. So that's the same way that we read graphs, okay? So we would call a line with positive slope as if it was going uphill from left to right. And kind of what helps me is I draw a little picture on it. Okay, he's going uphill, right? Okay, what if I was walking along this line? Am I going downhill or uphill?
Downhill.
This one is downhill, so this is a negative slope.
Looks like he's falling.
Okay, so positive slope is uphill, negative slope is downhill. We also have 2 other types of slope. we have a horizontal line that's just straight across. This is called a zero slope because my y values are not changing, right? So the rise is 0. Okay, this is an undefined. I have, so if we were to draw a man on this, he would fall off, right? Unless he had a rope. He had a rope. Undefined slope is a vertical line because the x values are not changing. So the denominator of your slope formula is going to come out to 0. Okay, so positive slope, negative slope, I'm going to underline that. Positive, negative. Zero slope is a horizontal line, and undefined slope is a vertical line. And we'll do examples of all of these. Okay, let's go back to example 1. Okay, part A, is this positive slope or negative slope? Is it going uphill or downhill? It's going uphill, so is it positive? Our answer came out positive, right?
Yes.
Okay, what about this one? Is it going uphill or downhill? Downhill, and it was negative. Okay, it will always work out that way. Always. Okay? Okay, so let's do an example of just using the formula. Okay? So we want to find the slope through 2 points. Really quickly, what 2 points are my y values?
2 and 6.
2 and 6, okay? So 2 and 6 are my y's. And do y's go on top or on bottom?
Top.
On top. So how we're going to do this is we're going to start with m equals and a fraction. And we need to subtract those y's first. Which one do you want to do? 6 minus 2 or 2 minus 6? 6 minus 2. Okay, so write it out. 6 minus 2. Don't do any subtraction yet. Okay. And then my x values are 3 and 5, correct? Okay. Now, I put 6 first when I was doing the y values. So that came from this point, correct? Which means I have to put the 5 first on bottom. So my point 5, 6, 5 and 6 are on top of each other. Does that make sense? So I need to use the same point first each time. So that would end up being 5 minus 3. Okay? Okay, so what does this give me now? 6 minus 2 gives me 4. And 5 minus 3 gives me 2. Am I finished yet? No, that reduces to 2 over 1, or since it's over a 1, we just have to write the 2. So my slope is 2. Okay? Okay, example 3. We have the points -1, 3, and 4, 8. So I'm going to start by writing my fraction. M equals...
Don't you turn it into a plus?
Yes. Okay, so which point do you guys want to use first? 8 minus 3? Okay, so 8 minus 3. Which means what goes first on bottom? 4 or -1? 4. Good. So 4 minus -1. Okay, make sure you put that -1 in parentheses first. Okay, I have minus and negative, so what happens? Becomes a positive. So that's going to give me on top 8 minus 3 is 5. And 4 plus 1 is 5. Does 5 over 5 reduce?
Yes.
Yep, to 1. So my slope here is 1. Okay. So example 4, m equals and a fraction. Okay, so what's going to go on top? -7 minus -5.
Ooh, I just got the answer.
Okay. And then which one comes first? -3 or -2?
-3.
-3 minus -2. Okay, now for this one, I have 2 minus a negative, so what happens?
Positive.
They all become positive, so this is the same as -7 plus 5 and -3 plus 2. So what is on top?
-2.
-2. And what's on bottom?
Negative 1.
-1.
Turns to positive.
So -2 over -1 equals
2 over 1
positive
or 2.
2.
Just got the answer.
Okay? Alright guys, I want you to do the last two by yourselves, 5 and 6. Okay guys, so most of you finished. Example 5, we have 5, 2, and 7, 2. What's going to go on top? 2 minus 2. And what goes on bottom? 7 minus 5. Okay, so that's going to give me a slope of 2 minus 2 is 0, and 7 minus 5 is 2. And what is 0 divided by anything? 0. So this is a 0 slope. Looking back at your chart just above, what would that line look like? Which one has a 0 slope? The horizontal one. So it just looks like this. There is no slope at all. Okay. What about example 6? What's going to go on top there? -7 minus 7. And so what goes on bottom? 6 minus 6. Good. Okay. -7 minus 7. What does that give me?
0.
-7 minus 7. Negative 14. And 6 minus 6 is? 0. Now, am I allowed to have 0 in the denominator?
Yes. No.
No, we are not. We learned this in like 5th grade. 0 in the denominator is not allowed. So this is undefined. Okay, so the slope of that one is undefined. What does a line look like if the slope is undefined? Vertical. It's vertical, so it's straight up and down. Okay, which means that our little man falls right off of the line. Okay, just think about it, guys, as if you were a little person walking on the line. If you're going up the hill, it's positive, right? If you're going down the hill, it's negative. If you're walking on flat ground, does that ground have any slope to it at all? No, it's just flat, right? And if you were climbing a mountain that was straight up and down, so like Half Dome, that part of Half Dome that's straight up and down, could you climb that without a rope?
Yeah.
You would fall right off, right? So it's undefined. Does that help? Okay.